Good evening. Hope you guys are doing good. I am Mr. Powers, and I'm ready to go over just some integrating with tables tonight. We haven't gotten to do that very much using tables, table of integrals to do integrals. It's not a method I really enjoy, and it's not one I care about too deeply. In the past, I usually just have little quizzes on them. You won't see them on tests very much. It's a good practice for algebra skills, basically. And hey, tables are nice. They can make some things a little bit easier. Okay, no, you can hear me. Sorry. I was messing with a lot of things here the other day, and I got all sorts of weird things in this. And I think I need to delete some things. I apologize. There we go. This is better. Anyway, so let's move on. Let's go ahead and do some examples. Okay? And so let's say we had this. Let's say we had the integral. Let's take the integral of x squared over the square root of 5 minus 4x squared dx. And you may see something like this and say, hey, I know how to do that. I can use a trig sub. And you'd be correct. It's like, why not? Let's use a trig sub. Probably would work. We see a root there. We're like, yes, trig sub. Use it. That'd be much nicer than, it's how we do it. But, we could look at the table of integrals in our reference pages. And that's right here. And try to see, does that look similar to any of these guys? These are the basic integrals. Here's something where we have a root a squared minus u squared, u being the variable. It's close, but it just has a 1 on top. We would like something more like a u squared on top. So let's see, is there one with a u squared on top? Maybe. Oh, hey, we'll look at that. U squared, and then I got a squared plus u squared. Not quite, but maybe if I keep looking, we'll find the one we're looking for. And this is what you do. So, I don't know. It's kind of annoying. Hey, there it is. That looks like the right one. And yeah, that is definitely the one we're looking for. Okay? And so, okay, great. I found it. I got u squared over a root, a squared minus u squared. Now, what I have doesn't look exactly like that, but I can totally get something that'll look like that. So I'm going to go ahead and I'm going to snip it just so I can quickly copy it, put it in. Nope, that's the wrong tool. Maybe it's this one. Hey, there it is. There we go. And let's just slide it up. Well, let's slide it up here. And then this, let's just get rid of that. Who cares? Delete. Okay. So anyway, we're going to use this guy. And let's make it a little bit bigger. Okay. Now, so what these end up being is there's two things. Find the formula we need to use, and then use it. Sometimes you need to be a little creative to use it. For me, there's a couple ways we could do this. I'm going to show you the way I would do it. And we'll see if it works. This it's not that. That's not it. But it's, I could mess with this and I could get it to totally look like that. Or I could use a u sub and get it to look exactly like that. There's a couple things I could do. I like to factor. I'm like, I can factor a 4 out of the bottom, a root 4, and I'll have it. So I'm going to go with the algebra way. Your book would have you do this. U equals 2x du equals 2 dx. and then use the formula. But I think that's unnecessary. But you can see if you did u equals 2x, that root would turn into 5 minus 2x 2x oh, I apologize. I'm sorry. Anyway, yeah, you can imagine here. I'm sorry. Had a brain fart. 2x squared is the same as 4x squared. That's where my head was at. And I had a little trouble here. And if you were having the same trouble as me, well, this really means the same as x is u over 2. And yes, if you replace that in there, you'd have 4 times u over 2 squared. The 4's are going to cancel out. You get a u squared. It is u squared. This is u squared. Okay? Or better yet, if that's u, what's u squared? 4x squared. Anyway, that's neither here nor there. I don't feel like doing it that way. Okay, you guys seen plenty of u subs. Let's just be creative. Look at this. I want it to be a u squared. That's my deal. That's what I want. So factor the 4 out. That's not that hard. So here, factor the 4 out, and we get x squared over factor the 4. Well, it's really a root 4. So I'll say root 4 times, let's see here. Factor a root 4, that's 5/4. So, 5/4 minus x squared. I made that a little long, dx. Okay. We can make that look nicer. Come on, let's do it. All right. There. Okay. Now I can totally use this formula. Real easy. What's my a? Well, I don't know. My a squared is this, so I can do a little scratch work on the side. Well, a squared is the same as my, a squared is the same as 5/4. So what is a? Square root top and bottom. A is root 5 over 2. Great. I can just now use the right side of this formula and rewrite everything. I got this 1 over root 4, which is 1/2, out in the front. I'm just going to take that 1 over 2 times the integral. X squared over root 5/4 minus x squared dx. And now that I've done the manipulation, or you could have done the u sub, but I just flat out a little algebraic manipulation, got it to look like the form I want it. Now I can just use it. So that's going to be 1/2 times, I'm going to use big bracket here, negative u over 2. Our u is the same as x, flat out. So it's going to be negative x over 2 times root a squared minus u squared. Well, we know that's 5/4 minus x squared plus a squared over 2. So 5/4 over 2. Let's just say that's 5/8 plus 5/8. Inverse sine. Again, and I'm looking at this formula up here. Inverse sine of u over a. So that's going to be x over 5/4, which is 4x over 5. We'll fix that later. And it is an indefinite integral, so we're going to go ahead and we are going to do, I'm just going to put the c out here, plus c. That'll be it. And then just to make it a tiny bit nicer, like I said, x over 5/4, we can do better than that, 4/5 x. And we can distribute the 1/2 in. But you know what? I guess. We'll distribute it. It's a little unnecessary, but we could do it. So negative x over 4 root 5/4 minus x squared. Could we factor 1/4 out of this root? We totally could. And maybe that would look nicer, and this would be, but who cares? I mean, there's lots of things we could do to change the way this thing looks. 1/2 times 5/8, that's 5/16. Inverse sine of 4x over 5. I don't know. I do want to do that. That bothers me for some reason. Plus c. And we'd call it a day. We say that's good enough. That looks wonderful. Unless I made a mistake. So it looks like I did. Oh. Did I make a mistake? Let's see. And so I did have something a little different than a solution that I'm looking at, but let's make sure we did this right. U over a, that's going to be x over, and there's my problem. A, I put in a squared. So I did have a problem. A is root 5 over 2. I did 5 over 4. So I'll just do a quick little fix that. We have root 5 over 2, which turns this guy into, let's see here, 2x over root 5. There we go. Mistake fixed. And if you are looking at this in our book, you will notice that their solution after they did the u sub did have a different answer. They did factor out the 1/4 here, which would get you 5 minus 4x squared, and the 1/4 root would turn into a 1/2, and they would have negative x over 8. It's the same thing though. So we're done. We're good. It looks great. If you wanted to factor out a 4th there to make it look a little nicer, you could, but it's fine. But you should recognize, if you're checking your solutions on Wolfram Alpha, on GeoGebra, they could look a lot of different ways and still be the same thing. And you kind of get that after messing with those a lot and looking in the answers in the back of the book. You notice, hey, I got it right, but it looks different, but if I fiddle with it, I can get it to look the same. Okay, I want to do one more example with you guys before I post this. And that is, where is it? I want a new page first. Add page. And that is this guy. I want to go ahead and do the integral. Oh, and I need to zoom in a little bit. There. The integral, there we go, of x cubed sine x dx. And there are so many of these examples. Like I said, you can't go through every single one, but it is not very difficult. It is just messing around with the u subs and all that fun stuff. Okay. And so let's go ahead and take a look at our what are they called? Our table of integrals. There it is again. And let's see if we've got anything like this. X cubed times sine x. Or in this case, u cubed sine u. Here's a lot of trig functions, but nothing that looks like that. No trig functions, so we'll keep going. No trig functions, and you can see here too, we got like kind of, they're grouped in a way to make it easier to go through. It's not going to be these trig forms. Okay, now we're getting into it. Well, we got powers of sine, powers of cosine, secant. Still not what we want. Let's keep going. And of course, and this is another one too, that you say, hey, this looks like something I could do with integration by parts, maybe. If and why not? Like I'm saying, what we're doing here is most of these are doable in a different way. Okay, here I got something. This looks like something. And if you can't see it, it's u to the n sine u. That might do it, but it's still going to have a u to the n cosine u plus, and so we get that, and then the power of u goes down. So I'd have to keep doing that, and maybe I could just do that 2 or 3 times. That might do it. So that's definitely an option. Definitely an option. That would probably do it. Just use that 2 or 3 times. And keep going here. Is there anything else that looks like what we want? I want a u squared out front. Huh, I don't see one. Okay, so no, my original thought is yeah, it looks like that's the way we're gonna have to do it. This guy right here, play around with that. That one right there, and actually, because now what's gonna happen is gonna be cosine, we're gonna have to use 84 and 85 together. So again, this time I'll zoom in, get a little better snip. We're gonna snip this guy. 84 and 85. Looks right. There we go. There. Good enough. Okay. Well, let's use the first one. So it's obvious. Our first run through, we're going to use 84. And we have u is x, n is 3. Straightforward. So what we're going to get is integral of x cubed sine x dx is equal to negative u to the n, so negative u, which is x, to the n, which is 3, cosine u, so cosine x, plus n, which is 3, integral u to the n, well, we're not using u, we're using x, to the n minus 1, so that's 3 minus 1 is 2, cosine u, which is x dx. Got it. And you can see that, yeah, this is definitely something that would happen with integration by parts. And if you don't recognize that, you're not doing enough integration by parts. And I'd be a little worried. Okay? If you do recognize it, then hey, good. I'm glad we're doing awesome. All right, so now we got to use this guy. And so this guy, and I'm being really careful, right? U is x and n is 2. I'm going to do it again. Like, all right, great. So I have negative x cubed cosine x plus 3 integral, plus 3 times. Okay, so what am I going to get? 3 times u to the n, so x squared sine x minus n, which is 2 now, times the integral of u to the n minus 1, which is just x, sine x dx. Getting there. And I'm going to be careful and simplify that a little bit before I go any further. And don't forget, you guys are watching a video here. If I'm going too fast, which I don't know, I always feel like I'm going too slow. I'm always being very thorough. I feel like, but who knows? You guys let me know. You can always pause it. You can always speed it up too. Nice thing about videos, right? That is the nice thing. The bad thing is you have to be disciplined enough to watch them and use them. That's a pain. Okay, so I got that simplified. And now it's x sine x. The integral of x sine x. And that seems familiar. Wait a second. Oh, yeah, and yes. So that is something that we have looked at before. And we could do, well, actually, could we do? Why not? We could even just use the formula again if we want. We got this again, right? X to the 1. Could use it again. But I think you get the idea. So I'm going to just go ahead and write the integral of this in there. And we'll be done. Okay, so it's negative x cubed cosine x plus 3x squared sine x minus 6. And this is going to be sine x minus x cosine x. Anyway, so we did it. Yay. No more dx. We just have a good old-fashioned plus c. And we can do another little bit of distributing and we'd be done. So I don't know. In this case, it was faster than integration by parts, and it is a method for integrating. It's just boring. I don't like it that much. I'd rather figure it out on my own, do the integration by parts, do the trig subs. I think it's more fun. Sine x minus plus 6x cosine x plus c. I'm looking at it and I'm not seeing much other simplifying steps that could be done. So I would say we are done. That's it. That is it. Done, done, done. So there's a couple examples of using the formulas. And there are, you saw, very, very many formulas. It is not just a few. Here we got 85, and I want to say that is the bottom. Is that the bottom? 86, 90. Okay, we got page 10. I don't ever give you much with a hyperbolic, but I mean, if we're using tables, why not? But got 120 of these, but really the ones you should know a lot of those already. Those you shouldn't know. Those you shouldn't know. These we should know, right? Basic forms. We should know a lot of those. So we can use these. Anyway, that's how you use them. That's it. Another video going up for you guys.